Now, let's just, how about, let's think about this, right? Think about yourself. Well, messy circuit, very complicated. The first thing I will find is to look at where is the input, where is the output. You need to do that, right? I give you an animal, ask you what animal is it usually, oh, where is the head, where is the tail, right? You even cannot recognize where's the head and the tail, you don't know what type of animal it is. So where's the input? I see it is here and this is output. And some of you as a human, you already broken down, you already can see what type of amplifier it is. But imagine if you don't know that, if you were a computer, you're doing computer programming, then you will do it step by step, right? So can someone tell me what type of amplifier is this? Well, very good. So he said cascaded, basically just say 2 stages, okay? He said this is common source. Do you agree? Now, if you don't agree, doesn't matter, right? Just think of it. What type of transistor is this? NMOS, yeah? And then you start what we learned at the very beginning. The highest potential is drain, right? The lower potential is source. And this is gate. And then now, yes, this is not the output of this whole circuit, but this is something I give to the next stage, right? So this is the output of this circuit, right? So input is gate, output is drain. So this is what type? Common source, like what you said, right? And now I go to the next stage. So this is the input, this is the output. It becomes the input of the next stage. Again, this is NMOS. So higher potential is drain, lower potential is source, right? And this is gate for sure. Then input is gate, output is source, common drain or source follower, right? Now with this, then you are ready. You know what equation to find for this amplifier, right? We are not going to solve anything. Let's think about what is the gain of this circuit. What can be the gain of this circuit? How do you calculate? Well, you already say it's cascade. It's 2 stages. Then why don't it's voltage to voltage? So basically, it's the gain of the common source times the gain of the source follower, right? So what is the gain of the common source? Negative GM RD. Let's ignore the channel length modulation because now we are in a more sophisticated circuit, and also we in this topic we care about only the input output impedance for now, so we can make it simple, just a GMRD, but it's good you know it's GMRD parallel out. What is the gain of the source follower in the first order or 0th order of approximation, right? You can forget all the complicated equation, but you go to an interview, people ask you, what is the gain of a source follower? You better say, it is 1. No use, it is 1. Yeah. Although it's GMR0 divided by 1 plus GMR0, then you can continue. It's okay you forget that, but it's not okay if you forgot that a source follower has a gain of approximately 1. It's just like it's not okay you forgot that an amplifier is for amplification. Of course, the amplification can be larger than 1 or smaller than 1, right? True, right? If you ask a middle school student or someone never use amplifier or study engineering, you say, do you know what is amplifier? Maybe they really don't know. They need to check the dictionary, right? Just like they give us a psychological term, we need to check the dictionary also, right? So, but now this imprinted in your mind, source follower must have a gain of 1, ideally, right? Maybe it is not. Okay, so good. This is equals to GMRD. Based on the drawing, what type of amplifier is this? Sorry, what type of, I'm talking about these 4 types. Voltage, transimpedance, transconductance, current. What type of amplifier? Voltage amplifier, right? Which tells me that the input is voltage. Output is voltage, which we already know that. We find the gain, right? Okay. What is the input impedance of the of this circuit? C in, C out, right? This circuit. This circuit okay, all right. Okay, you say infinite. He said infinite. Do you agree? Okay, because it goes into the gate, right? What is the output impedance of this circuit?
Going from the source of the transistor to the drain, so it has to do with that.
Source, it goes into the source of the transistor, so it has to what?
1 over GM2.
1 over GM2. Yeah,
Some up there, but
some of you is laughing, yeah, because it is up there. But that is great you explain. You did not just tell me 1 over GM2. Is this okay? What is the ideal input impedance that I want to have for a voltage amplifier input? The ideal one. Infinite. How about the ideal output impedance? 0. So do you think this is a good voltage amplifier?
Yeah. Well, GM2 has to be really large.
GM needs to be large. So we say this is a good voltage amplifier because 1 over GM usually is small. We consider it as small in our analog circuit, right? In the practical use. So can you tell me why we need a source follower if the gain is still negative GMRD? Why we want to waste the currents, the power, the area? The output what? Output impedance, right? Because if no source follower, what is the output impedance of a common source? It means, know this part, when I stand here, what is the output impedance? RD, parallel R0, right? RD. Is this large or small? It is large. Then it makes this a bad voltage amplifier. Okay. But some of you might say, well, you don't need to be large, let's just make it small. You are the designer, you can just make it small. What is the problem of making this small then? Why don't you just make it small? Then you have a small output impedance.
You'll change the gain.
You will change the gain. What is the gain? Again? GMRD, right? Yeah, you can make it small, but you have a low gain. Then your amplifier is no use, right? So now you see that now I have an extra stage. I decouple the output impedance and the gain. So I can make a very large RD, so I have a high gain. And then I have this stage to transform the impedance to a lower output impedance. So now I have a high gain amplifier with a low output impedance, and I have a very good voltage amplifier. Yeah. So all these things are not new to you. You know, you can solve it already. You understand everything already, right? But now we just look from this perspective. Any questions? If no, then let's move to another type of amplifier. This is what type of amplifier?